This video is about solving radical equations and inequalities. So, how do you solve for x when you see something that has a square root in the equation? Okay, so when you're solving these, when you're solving radical equations, the first thing that you need to do is isolate the radical. So, if you see something like this that has a square root in it, and it has a number in front of the square root, you need to get this part to cancel out, so you have just the part with the square root by itself. You need to isolate that first. So for this one here, you would have to start by dividing both sides by 2 before continuing to solve. And here, before you do anything else, you need to get the radical part by itself. You need to isolate the radical. So you would have to start with subtracting 3 to the other side first. So the first step when you're solving these is to isolate the radical. The next step is to raise both sides to the power of the radical. So how do you make the radical part cancel out? By raising it to the reciprocal power. So you know that square root is the same as 1/2 power, right? So since square root is the same as 1/2 power, you are going to have to square this to make the square root cancel out. Okay? Squared and square root will cancel out. Or what power would you have to raise cubed root to make it cancel out? Well, since cubed root is to the 1/3 power, the reciprocal of 1/3 would be 3/1. You're going to raise this to the 3rd power to make the cubed root cancel out. And to make the 4th root cancel out, you would have to raise it to the 4th power. Okay, let's go ahead and do a lot of examples about this. Please go ahead and write these examples down, students. Okay, so my first example here, I need to start by isolating the radical. So I need to get rid of this 5. So my first step is going to be to divide both sides by 5. Now my 5's will cancel, and I just have the radical left. Next I need to make the radicand cancel, and since I have a cubed root, I'm going to raise it to the 3rd power in order to make cubed root cancel. Cubed root and cubed will cancel, and I just have 4x plus 3. And here I have 3 to the 3rd power. 3 times 3 times 3 is 81. And here I have 3 to the 3rd power. 3 times 3 times 3 is 27. Okay, so now it's easy for me to solve. I can just simplify and solve like normal from here. I'm going to subtract 3 to the other side and divide by 4 to get the answer. So x equals 6. Let's do another example. You can see that we have a square root on both sides. So I'm not really going to be able to isolate the radical per se because I have it in 2 places. So let's start by making that radical cancel out. Since it is a square root, I'm going to square this entire side, square it, and take the entire other side and square it. So, squared and square root will cancel, and I just have left 35x. I need to distribute my exponent to both things that are inside the parentheses. So I'm going to have to do the 5 squared, and then also this square root squared. So 5 squared is 25. The square root will cancel with the squared so that I just have x plus 2. Okay, and that was the tricky part. You just have to know that when you see radicals on both sides, you need to go ahead and make that whole thing cancel by squaring it. Now we can just solve it like normal. So I'm going to go ahead and distribute. Subtract 25x to the other side. That gives us 10x equals 50. Dividing both sides by 10 gives us x equals 5. Alright, next example. Okay, in this example, it looks like I have the radical already isolated on one side by itself. So my first step is going to be to make the radical cancel. So in order to make it cancel, I'm going to square this entire side. And when I square this side, I must also square the other. So square root and squared will cancel, so that I just have x plus 18. On the other side, though, I have x minus 2 squared. Well, x minus 2 squared is x minus 2 times itself again, right? So I'm going to have to actually FOIL that out. I'm going to have to distribute x minus 2 times x minus 2. When I multiply that out, I'm going to have x times x is x squared, x times negative 2 is minus 2x, minus 2 times x is again minus 2x, and negative 2 times negative 2 gives me positive 4. Now I can just combine like terms and work my way towards the answer here. So, first of all, when I'm combining like terms, let's just keep this x plus 18. We would have x squared minus 4x plus 4, right? Okay, so now, combining like terms, let's, we have a squared here. So my strategy right now is in order to solve for this x, I'm going to make the whole thing equal to 0. Then I'm going to have to factorize it. So let's move the 18 to the other side and the x to the other side, one at a time. Why not take the 18 first? So minus 18. Combine it with the 4 since those are like terms. And 4 minus 18 gives us negative 14. Now subtracting the x to the other side will leave us with a 0 on this side. Okay, so now I can factorize this. I'm looking for two things that will multiply together to give me the previous line. So, 0. X times x will give me x squared. 14. 14 is 7 times 2. All right, and if I have a 7 and a 2, and I want to make negative 5, I'm going to do negative 7 plus 2 to give me negative 5. So negative 7 and a plus 2, and negative 7 times positive 2 will give me negative 14. So now, to finish solving, we simply take each part and put it equal to 0. X minus 7 equals 0, and x plus 2 equals 0. So, that gives us x equals 7, and x equals negative 2. Now, because we have these square roots though, we need to go back and check our answers, plug them in, to make sure that none of our answers are extraneous. If I plug in 7 into my original equation, I would have 7 plus 18, that's square root of 25, and the square root of 25 does in fact equal 5, so 7 is a solution. Check. What happens if I plug in negative 2? I'm going to have the square root of 16 equals negative 4. Well, the square root of 16 does not equal negative 4, it equals positive 4, so that's not a solution. So that means that our solution is x equals 7. Does not equal to, this is extraneous. All right, great. Let's do another example. Okay, and last example for this particular type. Here we have raised to a power, here we have a, last example for this particular type. Here we have a polynomial raised to a fractional exponent. So, how can we make that exponent cancel out? Well, I can make 1 over 5, the exponent 1 over 5 cancel out by taking it to the reciprocal power. So, reciprocal of 1 over 5 is just 5, or 5 over 1. Okay, so I'm going to take this to the 5 over 1 power. And when I do that to this side, I also have to do it to the 2. 5 over 1. 2 to the 5. So now, 1 over 5 and 5 over 1 cancel out. And when they cancel, I simply have 3x minus 1. On the other side, I have 2 to the 5th power. 2 to the 5th power is 2 times 2 times 2 times 2 times 2, which is 32. And from there, you guys can do it. Add 1 to the other side. Gives us 33. and divide by 3 for the final answer. Good. All right, now let's talk about inequalities. Okay, so now let's talk about solving radicals that are inequalities. So, when you are solving inequalities, you can solve them pretty much the same way that you solve equations. The only difference is when you're solving inequalities, remember you have to flip the sign if you flip the direction of the sign from being greater than to being less than, if you multiply or divide by a negative. So do you remember, if you're solving for x and it looks something like this, and you end up having to divide both sides by -3, well, when you divide by -3 on both sides, it changes the sign from being less than to being greater than, or from being greater than to being less than. You have to flip the sign if you end up dividing by or multiplying by a negative number. So I don't know if that really comes up, but that's the only difference with solving inequalities. So now, when you're solving inequalities though, we have to look out for getting a negative inside the square root. You cannot have a negative inside the square root. If you do have a negative inside the square root, that gives you an imaginary number. So at this point this year we haven't learned about imaginary numbers yet, but it is, so before when we were solving them and we were getting one answer, when we had x equals one thing, we didn't have to worry about it because we were plugging our answer back in anyways to make sure that our answer worked. But now that we have inequalities and we can get a whole range of answers, we have to make sure that the x values we're using don't give us a negative under the square root, unless you want an imaginary number. So if you were to get a negative under the square root, like the square root of -25, we would break that down to be like, okay, well, -25 is 25 times -1. Then you take the square root of each part. Square root of 25 is 5, square root of -1 is I for imaginary number. How we make sure that we don't have any negatives under our square root is, we take whatever is under the square root and you're going to set it greater than or equal to 0 at the end, just to check to make sure that those are x values that we can have. So we need to make sure that whatever is under the radical is greater than or equal to 0 when we finish. So let's do an example. Okay, so let's go ahead and solve. Here we have a radical equation and it's an inequality. So the first thing I need to do is to make the radical here cancel out. So in order to make square root cancel out, I'm going to have to square both sides. The square and the square root cancel, and I have x squared plus 4 is less than or equal to 16. And I can go ahead and solve like normal, subtract 4 to the other side, which gives me 2x is less than or equal to 12. And then dividing by 2 gives me x is less than or equal to 6. Now, I know that. Now, the next thing I need to worry about is my original equation. My original, I cannot have any x values in here that would make this value under the square root negative. So, what I'm going to do is say that 2x plus 4, the part under the radical, needs to be greater than or equal to 0. So, take the part that's under the radical and say that it's greater than or equal to 0. So now we can solve like normal. We'll have 2x is greater than or equal to -4, and x is greater than or equal to -2. So now I'm going to write my answer. My answer has two parts. X is greater than -2 and less than 6. I'm going to go ahead and write that as a compound inequality. X is between -2 and 6.